All right, so we're going to talk about some expressing probability stuff and theoretical probability, which will be much more important as we go through the unit. So last time we talked about probability is experimental. So it's like if you're shooting a basketball, how likely it is you'll get the next shot. This unit, we're going to be talking more about theoretical probability, which is before you shoot any basketballs, what's your prediction of what will happen? And honestly, you're going to see why that one kind of falls flat. It's more about stuff like dice and cards and computers, not people. So, experimental probability is when we do experiments to try and see what's happening. Honestly, if there's anything with humans, anything going on with people, especially if it has to do with skill or it has to do with something that is hard to understand, we're going to use experiments and experimental probability. If it's something not with humans, but we're trying to predict, that is not complicated, that is very simple to understand, like dice, cards, spinners, all this stuff where it's kind of fair and you can understand what's happening, you can use theoretical probability. When you can't control all the factors, so something like weather, that would be experimental as well, because there's a lot of factors you can't understand. So probability is basically saying how likely is something to happen, and we need to be able to express it in a lot of ways. So let's take a basic example from last unit when we're like shooting a basketball. Okay, so if I'm shooting a basketball, let's say that I shot 5 times and I got 2 baskets. The way that we need to express probability is good outcomes divided by total. So in this case, we got 2 baskets out of 5 total. That's the probability. So we wrote it as a fraction, but honestly, we don't really like using fractions because they're a little bit hard to understand when we're talking about stuff in general. So we need to turn this into a decimal. So to turn it into a decimal, we just divide, because that's what the fraction means. So 2 divided by 5 is 0.4. But again, we don't really like using decimals either because they're kind of weird. So we turn this into a percent. So we need to do just times 100. So this will give us 40%. 40% we can understand. We know what that means because you understand what 40% is. It's not great, it's not 0, but it's somewhere in the middle. Words is when we need to be able to express, basically say, score 2 out of 5 times. It's basically just taking the numbers we have and expressing it in a sentence. Okay? Odds is something different that we're going to go through later, but basically the odds here is 2 to 3. So this one's really weird and different, and we'll talk about it after. So let's do an example with coin flips. Coin flips does not have to do with skill, or at least it shouldn't. It should be something that's controlled by a coin. There's only 2 outcomes, there's no special factors, there's nothing to consider, so we're going to use theoretical probability. That's where we can predict what should happen before we even do it. So in a coin flip, there's 2 outcomes. There's heads and tails. If I played basketball, there's there's infinite ways you can shoot a basketball. When you flip a coin, it's either it lands up or down. There's no sideways or any weird ways to go about it. So this is theoretical. So when we do a coin flip, there's 2 possible outcomes. One is good, one is bad. So when we do our probability, how many good outcomes are there? 1. How many total outcomes are there? 2. Okay, so the probability 1 out of 2, which is 0.5, which is 50%. Now, just think for a sec if you did experimental probability. Let's just say I flipped 3 coins, and let's say I got 2 of those 3. That would be a 2 out of 3, which is 66%. Or let's say I flipped 10 coins, and I got really lucky, and I got 9 out of 10. Does that mean I have some magical powers? No, this was just a bad experiment. So theoretical probability is really good when you're doing stuff that can be influenced wrong by bad experiments. Let's do rolling dice, similar example. So when you roll a dice, that's the little cube thing, okay, a die, there's 6 outcomes, 6 total numbers you can get. Let's say we want to get a 3, okay? So there's only 1 3 on the dice, that means it would be 1 out of 6. So we could convert that and figure out the percent. That's how we do probability. Odds is a little different. Odds is when we compare good versus bad outcomes. There's no total. Okay, so if we do this dice example, the good outcomes, there's 1. And then we put a colon to say we're comparing, and how many bad outcomes are there? So on this dice, there were 6 sides. It is not 6, because there aren't 6 bad outcomes. There's only 5. What you'll notice is these 2 numbers, we'll add to make the total. Okay? If we're going to do the odds for the coin again, so the coin probability is 1 out of 2, which is 50%. If we want to write this as a ratio on showing the odds, we would say the odds of getting a good outcome, like a head, is 1 to 1. We say this is 2. 1, 2, 1. Okay? So in this case, the probability is 1 to 1, which means it's the same. And we see in this case, when it's 1 to 5, we can see that the odds aren't great. If you had something like this, the probability is very, very bad because the chances of getting the good outcome is only 1. The chance of getting a bad outcome is very, very high, 999. So the bigger this number is compared to this number, the worse your odds are. And that's it.